Good morning and welcome back again to the class. Today we are going to cover or finish our section with 8.3, eliminating square root. We stopped here, I think, and I'm going to finish that section with you. So eliminating is inside cosine and cosine function. I'm just going to remember you that the starting of this section, the name or the title of this section is what? It's trigonometric integrals. Means that how to play with it. For example, we say that if I have direct, if I have indirect, together sine, cosine, how to play with it, right? For example, if you have just only cosine square, we use that one. If I have one with the odd exponent, we use one of them and we make it as a outside, we make it as a dx or anything, du, whatever you like to call them. But today we have something else. We have eliminating square root. Eliminating square root means that maybe you have something under x and you try to change it to y squared to get y. And which one we can do that? Just only we have these shapes. For example, we have 1 minus cosine x, or we have 1 minus sine of x to x. Okay, so if I have x, if I have 2x, if I have 4x, all of them, they have the same. We can solve all of them by the same idea. That's why I called alpha. Alpha, let be 1, 2, 4, and any number that you like to call it. Understood? So which shape we have, which type we have, those types. Now, how we solve them? For example, if I have the simplest one, not like that. If I have the simple one, maybe in your lecture note you have. We should use this identity. We know. We say cosine square of x is equal to, we should use half angle. We should use 1 plus cosine 2x over 2. Again, sine square of x, we have 1 minus cosine 2x over 2 again, right? So we use that one. So I'm going to change here and there, but to something square. How? By using that properties. Now I'm going to start with the easiest one. 1 minus cosine, for example, x, or we have 4x. So how we solve that one? How we change that one to something square? Now I say cosine, because I have minus, so it means that I have what? I have this rule. If I have plus, I'm going to use that one. So here we are. I say cosine sine of something is equal to 1 minus cosine 2x. So here we are, because I have 4, means that I have what here? 8. Are you sure? No, it's reverse true. I have 2. If I have 2, 2 by 2 is equal to 4. Understood? If I have nothing, if I have 1, here I have 2. If I have 2, 2 by 2, I'll get 4. That's why we have 4. Here's double, here's half, okay? Here's, okay, no. So over 2. Now we multiply both sides by 2. I'll get what? Am I right? Then I'm going to take down here squared. Do not forget about that. And now I'm going to take a square root to both sides. Am I right? Also, I can take integral to both sides and I can answer. That part is easier. Why? Because squared. So instead of writing 1 minus cosine, 1 minus cosine 4x dx, I'm going to solve 2 sine squared x dx. Am I right? And I know that one will be what? Will be square root of 2 sine of 2x dx. Understood? Why sine? Because that one with that one will eliminate. So I'll get sine 2x. And I know how to solve that one. It's easy. So I see is equal to cosine 2x over 2 plus c. So you multiply and you'll get something. That one will be minus cosine 2x over square root of 2 plus c, whatever you have. The important thing is idea, how to get it. Okay. من minus كم بروح الكدي? I solve the minus for you. In your lecture notes, you have plus. Nothing changed. So the same idea, the same property. You can see, right? Nothing changed. So try to use that one. Try to solve both of them, and you'll get more idea. Do you have any question about that one? So the first, we solve the sine and x, cosine and x dx together. If that one or if that one or if that one even or both even, we solve that one. Then another idea, eliminating square root, canceling, deleting square root by using these properties. And then now we are going to take a third idea in 8.3. Any question about the second idea? The second examples, the type of the examples? Clear? No question? Good. Now I'm going to deal with what? Tan and secant. Why tan and secant? Why? We say sine, cosine. Here we say tan and secant. Why? Can you give me any clue? Do you have any idea what I'm talking about? We know first secant square of x is equal to what? Right? And again, I know also secant tan is equal to what? Is equal to, okay. And also I know the third idea. I know if I have tan of x, secant square of x dx is equal to what? That's the new. But you saw, maybe you guessed. Tan square y, you don't know. Yalla? You make that a little bit complicated, you expand it. No, the idea is something else. Here's box, here's D box. Easy, right? You should deal with it one by one. So secant square, I know, is equal to tan. So derivative of tan is what? Secant square. So now I am changing that one to tan square over 2 plus c. In the previous lecture, I remember that I gave you that idea. Tan of square of x is equal to tan of x square. Am I right? We deal with that one, the sine and cosine. The same thing is true for the other function. Now, number 4, example number 4. Tell me how I solve tan square of x, secant square of x, dx. Tan cube, you are right. Why? Because again, we have box, d box. But the box is square, am I right? We can change that one to here. So I will get tan cube over 3 plus c. Did you understand what did I do? So tan 4, tan 5. With the second, the important thing is what? We have d box. The d box of tan is what? Secant square dx. Did you understand? So if I have tan with any d box, it's easy for me. Understood? Dear, understood? Good. So now I'm going back to that one. So I have tan square, tan cube. How we change that one? How we change tan to power 4x dx. The important thing is to get d box, tan with a d box. Or the important thing is what? To get secant square from that one, right? So how I get that one? Which idea? Before solving that one, I'm going to remembering you some identities. In Cal 1, you got it. You know about that one. Sine square of x plus is equal to what? Is equal to what? Okay, good. This is the equation. So I'm going to divide that one, okay, by sine inverse or by cosine inverse, cosine square, not inverse. I'm going to divide all of them by cosine square, cosine square, cosine square. So I'll get what? Sine square over cosine square? Huh? Tan square, thank you. So I'll get tan square. Good. Plus 1 equal to secant square. Now this is another identity, right? Without memorizing, without, what do you say? Say, just we have that property, it's easy. And I'm going to divide by that one by cosine square. And we got this double star. From equation star, I got the double star, it's easy. Okay, so to changing tan square of x to secant square of x, I should do what? I should say is equal to minus 1. Am I right? Understood what did I do? From the equation double star, I say tan square is equal to secant square of x minus 1. Understood? I'm going to use that one a lot. Now, going back to your example, you have idea that with tan, we need secant square, right? So how I change this tan? I say is equal to tan square multiplied by tan square dx. Why? Because I am going to change that red to d box. Understood? How? I am using that identity. So I say is equal to tan square x, that one will be secant square x minus, right? Minus 1 dx. Understood? Then we multiply because I want to get d box. So I'll get what? Tan square secant square of x minus tan square dx. Am I right? Okay. So how about that one? I have what? Box, d box. Thank you. Now you know what I am talking about. So I'll get what? Tan cube over 3, right? How about the second integral? How about the second part? How I solve that one? Same idea, right? Same idea. I'm changing to the box, d box. So I'll get what? I'll get second square again minus 1 dx. Without result again. Without result again. So I'll get what again? Second square of x plus dx. Am I right? True? Good. And you know, integral of second square. Understood? Do you have any problem? Hello? Understood? Good. So here we are, we change it to that one. Why? Because I want to multiply by that one. Good. So that one is box d box. Okay? That one is box d box. You say that. So I'll get what? I'll get 1 over 3 cube. And how about that one? How I solve that one? I know that one is direct. That one is equal to x. So tan and x. Understood? Any question? Good. So, do you have any question tan with second square? So if I have a tan to power 2, tan to power 4, 3, how I change it? Hello? You got it? Good. So try to solve tan to power 3, for example, at home. How to solve that one? Okay. Now I'm going to second. Second alone. So if I have second of x dx, the result will be what? The result is equal to what? Kindly check the videos. Cal 1. 3 times I solved that one. Do you remember? We multiply by something like that and you get that answer. Do you have any problem with it? You don't know how to do? We do like that 2 times, I remember. So in 8 points, or I think so in chapter 7, we reviewed. So kindly check the video, 8.1 or 8.2, I don't know, the videos. The second inverse we mentioned before is direct, right? So now, how about second cube of x dx? How we solve that one? Actually need new idea. It's not easy. You should listen with me. Maybe if you don't know that one's okay, but those is not okay. So how we solve that one? I say I'm going to solve second square like that, like second of x, second of x dx. Understood? So look at here. We make it like that, second by second square. And I'm going to use by parts. So I cannot solve directly, or I cannot solve by a small idea. I need big idea, great idea here. So I say by parts, because I have 2 functions, u dv, don't say du. You have dv, because I'm talking about parts, 2 parts. So I say let u be second of x, and dv be second square x dx. Second step, derivative of here, integral of there, right? So derivative of u du, derivative of second, no, derivative second tan. Understood? So integral of dv v, integral of second square tan. Now I say I our integral is equal to uv minus v du. So uv secant of x tan of x minus v tan of x du equal to what? Am I right? You got it or not? Question, yes. Repeat it. Okay. Now I'm going to repeat all, okay? Forget about that. We say that I equal to secant cube of x. I cannot solve that one, so I'm going to change it to secant of x, secant square of x dx. Understood? Now I'm going to use that one, solve that one by parts, by UDV method of 8.2. So I say let u be secant of x. How about dv? dv be the second part, fg. So be what? Secant square dx. Now, the second step of u du is taking the derivative of here, of u, and integral of the dv. So I'll get du, derivative of secant is equal to secant tan. So I say secant tan x dx. Understood? dx, not du. Okay. How about integral of dv is equal to v? How about integral of here is equal to tan? It's direct. Now I say I is equal to secant cube. Do not forget about that one. Okay, our question. I say I equal to uv, so secant x tan of x minus v du. V du, multiply tan by tan square x secant of x dx. Now it's clear? Dears, did you understand? It's very important, that example. So IC is equal to what? IC is equal to secant tan minus. I should change this secant to what? Sorry, this tan inverse, which is secant square of x minus 1. Do you remember that? Multiply by secant dx. I'm going to write down like that, minus secant by secant minus by minus. Am I right? Second by, or maybe I skipped a step, so I'm not going to skip for you. Okay. So I see is equal to secant cube dx minus secant of x dx. We multiply here, right? Then in the next step, I have the same. I have secant cube x dx minus integral secant x dx. And I know I equal to that part, secant secant tan, I'm going to write down here. So secant of x tan of x minus secant cube of x dx minus ln Am I right? How I solve second? How I solved? We say that in Cal 1, revision of Cal 1, you can check it. So how I solve that one? Isn't that one I? Am I right? So I got what? I got something minus I minus something. Understood? So I'm going to bring to I to the other side because I got minus I. So I'll get what? 2I equal to second tan minus ln of second plus tan plus C later. So I say I equal to second tan minus ln of second x tan x plus C. Here you are. We have u du dv tan, then uv minus v du, and you will get that one. And here's the result. Understood? So there was many ideas. The first, we changed, that's why I say great idea. The first, we changed to second and second square. Then later we solve that one together, right? We make it by parts, the second idea. We make the u dv. Then the third place, we do what? After replacing u du, we got I, again I. This is the third idea. So 3 or 4 ideas here. You can play with it. Understood? You don't get that example actually if you don't solve at least 2 times at home. So try to solve it. Understood? And do not forget about this chart in your mind, how to study. Second, yes, second is like that. Second squared, yes, is direct. Second cube, no, we cannot solve it. So do you have any question? Now again, if I have second m, if we have tan to power something with the second to power something, it's your turn to give me idea. So how we solve that one? For example, if I have such example like that, tan cube to power 4, sorry, second to power 4. So how we solve that one? Which idea we need? Yalla. 2 ideas is here. Which with what? Which? Which was square? So tan to power 4 and second to power 4. Tan. Any idea? Yes. Box D box. Okay, you are right, box D box. But that one to power 4. D box should be like what? Thank you. So we change that one. Look, we change to, now I have, look at here. The example is like that. I have tan to power 4, second to power 4, x dx. The idea I told you, to get d box. What's the d box? Second square dx. Am I right? So I have second to power 4. So I'm going to change that on 2. Do not change tan, because tan is box. We should change all of them to box. Okay, so how? I have tan to power 4x. Now I have second square of x. Now I have second square of x dx. Now I got d box. Am I right? And that one is box. How about that one? I should change it to what? To get box. Exactly. We should change to the other opposite one, right? So I'm going to change that one to tan square plus 1. And I have also tan to power 4. You should change all of here to the opposite. What's the opposite of secant square? Tan. No, just tan, right? Because I know the opposite of secant square is tan, because the secant square is d box. That's why. So I'm going to multiply, again, d box here. So I'm going to multiply that one. I'll get tan to power 6x plus tan to power 4x, right? Multiply by what? Understood. Now it's easy, right? I have box, d box. Again, box, d box. Now we multiply. I'll get tan to power 6 secant square x dx plus tan to power 4 secant square x dx. And here we are. That one is box, d box. Again, that one is box, d box. Understood? So in case tan with secant square is okay, but if the secant is not square, try to separate secant square to the other side and try to change the other seconds to tan. Understood? These two ideas together. First idea, get secant square. Second idea, change the other to the opposite, like a sine and cosine, right? So I'll get what? The result. Yalla. 7 plus 5 plus. Understood? Hello? You get the idea? Good. It's not hard, but actually need work because we got money. So later, I'm going to review the 8.3 for you, all of them. Another idea. So we got sine idea of 8.3. We got sine, cosine, and m. Am I right? That's not the first. The second idea, it was what? Like eliminating square root, right? How to eliminate. The third idea, it was what? Tan n secant m. Am I right? Yes. The fourth idea, we have sine, cosine, product of sine, cosine. Product means that I have sine, cosine, but with a different angle. For example, that one 3, that one 4. They are different. It's not, if they are not different, it will be easy, right? Understood? For example, if I have sine 3x multiplied sine 3x dx. So in that case, I'm going to use here. Understood? First idea. Why? Because I say that one's box derivative of sine 3x is equal to what? Cosine 3x multiplied by 3. Right? So I'm going to raise that one to 2 and divide by 2, and I'll get the result. But if I change that one to 4, it will be disaster. We cannot solve like that one. So I'm going to use another idea, new idea for you. So careful. So if they are not at the same angle, we should use another idea, which I think I remembered you something. Do you have any question about that one? Did you get the idea, or the fourth idea in 8.3? Fourth part of 8.3? Clear, dear? Okay. So I'm going to find these rules. I should know if I want to solve something like that, or like that, or like that, we should know about, look, here I have cosine, cosine, but the angle different. Now here I have sine, cosine, but the angle different. How about here? I have sine, sine, but the angle are different. Understood? Do you have any question? The important thing to understand what I am going to do. Later you will understand everything. So if in case we have multiplication between two cosine, or multiplication between two sine, or multiplication between cosine sine, but with different angle, I'm going to solve it by that one, by that idea. I need these rules, 3, 4, 5. I need all these ideas. So how I get these identities? Yeah? How I get that one? It's easy. We did like that before. I remember that. Yes, I'm going to give you a clue for one of them, okay? And the rest depends on you. So if I have sine A plus B, which is equal to what? Sine A cosine B, right? Cosine A sine B. You know about that one. How about A minus B? Sine A cosine B, cosine A. Do you have any problem with that one? So I'm going to add them, addition. I'm going to sum of them. So sine, sine, I say is equal to sine, left side of the equality. I'm talking about adding the left side. So A plus B plus sine A minus B. Am I right? Clear. Now adding this one, I'll get 2 sine A cosine B. Am I right? And the other will be 0. So I'm asking about that one. So sine of A cosine of B equal to what? Understood? You got that one? Good. So I'm asking you, kindly pay attention. I'm asking you, if I have integral of here, is true to equal to integral of here or not? Equal, right? It's true. So for example, if I have sine of 2x cosine of 3x, they are multiplication, right? Right? Sine multiply cosine. And the angle is what? Different. So how I solve that one? I say is equal to 1 over 2. Sine A plus B, I say 5x. Plus sine A minus B, I say minus x dx. Understood? And I know these integrals are easy. Why? Because I know it's equal to 1 over 2 sine 5x dx minus sine x dx. Am I right? True? You know, the sine negative inside of the function, because sine is odd function, will go to out. So, and I know derivative integral of here is very easy. Is equal to minus cosine 5x over 5 minus minus cosine x over 1 plus c. That's the answer. So that one, it was what? If I have sine 2x cosine 3x dx, because I have multiplication between sine, cosine, and because the angles are different, so I am going to use these cosine, cosine here, this identity. Understood? IC is equal to 3 minus or 2 minus 3 and 2 plus 3, and I go the integral. Understood, dears? So I'm asking you another question. If I have integral of cosine 5x cosine 8x dx, so how we solve that one? I have cosine, cosine, angle, angle. So I'm going to use using that identity. But how I get that identity? Is by memorizing? No, by using these properties or this property, okay? To get the sine, cosine, 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 try to use that one twice by addition and subtraction, and you'll get the answer. Understood, dears? So kindly do that one at home. You need to. So let me see such example. I have 3, 5 sine, cosine. So how we solve that one? I see is equal to 3 minus 5 and 3 plus 5. Understood? And I get that one. That one, it's easy. So that's all about that one. I try to help you more. So I'm going to find another one for you. Another of that one for you. So I have what? I have cosine A plus B and cosine A minus B equal cosine of A, right? Right? Cosine of B minus sine A sine B. How about that one? Cosine A cosine B plus sine A sine B. Now add them. When you add them, that one you will get what? You'll get 2 cosine. Let me do the left side first. I'll get cosine A plus B plus cosine A minus B is equal to 2 cosine A cosine B. So I got cosine, cosine, right? I got that rule, cosine, cosine. Now, if I subtract these two equations, this one will remove, I will get sine, sine. Understood what I say? So that's all about rules, identities, ideas in 8.3. It contains 4 great ideas. Do not forget about that one. So, and we see how to solve them one by one. How we solve all these ideas together. Do you have anything? Here's the ideas. Do you have any questions, dears? Nothing? Okay. So you'll take a rest for 10 minutes. Just